Hey everyone, and welcome to today's Explainer. We are diving straight into something that literally impacts every single person on Earth, our global food supply. Look, we're currently facing a massive agricultural crisis. Our population is growing, our resources are shrinking fast, and the old ways of farming? Well, they're simply reaching their limits. But what if the solution to feeding billions of people isn't something huge, but something unimaginably microscopic? Today, we are exploring a major, game-changing leap forward in agricultural technology. 50%, just let that sink in for a second. We're talking about nearly half of all agricultural soils on the planet suffering from severe zinc deficiency. When the soil is starved of essential nutrients, the crops are starved, and ultimately our global nutrition takes the hit. The stakes for our crop yields and human health have honestly never been higher. Okay, let's dive into this. Here's our roadmap for today. We'll start with the global fertilizer problem, meet Nano-Urea, zinc, look at the smart nutrient delivery, see how it's supercharging plant growth, discuss saving water and earth, and wrap up with the future of farming. Starting off with Section 1, the global fertilizer problem. So, nitrogen and zinc, they are absolute necessities for plant survival. Plants literally can't grow without them. But here's the issue. Conventional fertilizers usually supply these nutrients separately. When farmers dump traditional urea and zinc onto a field, it acts a lot like a massive sugar rush for the plants. The release is so rapid, and because the plant can't possibly absorb it all at once, huge amounts are just lost. This leads to terrible efficiency, skyrocketing costs for the farmers, and severe environmental contamination as all those excess nutrients wash away. What we desperately need is an ideal solution, an efficient, controlled delivery system that is both cost-effective and actually sustainable. Which brings us to Section 2. Meet Nano-Urea ZnO. This is our microscopic hero, designed specifically to solve all those massive inefficiencies. Let's define exactly what we're looking at here. Nano-Urea ZnO multifunctional fertilizers are engineered nanocomposites. Basically, they combine nano-urea, which is our nitrogen source, with zinc oxide nanoparticles. The result is this highly intelligent, controlled-release nutrient delivery platform. And I really want to emphasize this point. It's not just dumping more fertilizer on the problem. It is a fundamentally smarter delivery system that acts almost like a time-release medicine capsule, giving plants exactly what they need right when they demand it. Moving right along to Section 3, the smart nutrient delivery. Now, you might be wondering, how do we actually make this incredibly tiny technology, which measures just 20 to 80 nanometers? Well, what's really fascinating here is a process called green synthesis. We can actually use phytochemicals, which are essentially natural active compounds, extracted from everyday plants like neem leaves, papaya leaves, and even green tea. These natural plant compounds act as reducing and stabilizing agents to build these advanced nanoparticles. So we're literally creating this super high-tech farming solution in a completely eco-friendly way. Once we've got our nanofertilizer, here is how the actual delivery mechanism plays out in 4 precise steps. Step 1 is application, and it's super versatile. You can spray it on leaves, mix it into the soil, or even treat seeds with it. Step 2 is where the real magic happens, controlled release. Instead of that wasteful sugar rush, these nanocarriers regulate the nutrient flow, providing a nice, sustained availability over time. Step 3 is absorption, where it easily enters right through the roots or leaves. And finally, Step 4, translocation. The nutrients move smoothly through the plant's internal plumbing, the xylem and phloem, directly to the active tissues that need them most. It's essentially a sustained IV drip approach, which is vastly superior to the wasteful methods we used to rely on. Let's look at Section 4, supercharging plant growth. If we zoom out from the microscope, what actually happens to the crops when they get this targeted medicine? Well, you get this incredibly powerful synergy. Nitrogen does the heavy lifting, building vital chlorophyll for photosynthesis and proteins for biomass. Meanwhile, the zinc acts as the crucial spark plug. It helps create essential growth hormones for massive root elongation. It jumpstarts over 300 different enzymatic reactions, and it builds up a robust defense against stress like drought. Put them together, and you've got a powerhouse plant. And the versatility here across different agricultural sectors is absolutely mind-blowing. We're talking about supercharging everything from staple grains to veggies. With rice, you see increased tillering, meaning way more productive stems per plant. Wheat develops higher grain protein. Maize packs on more biomass. It even works wonders on vegetable crops like tomatoes for better fruit yields, and on plantation crops like tea, massively boosting leaf biomass. It's universally beneficial. All right, Section 5, saving water and earth. But hey, the benefits don't stop at just bigger harvests. This microscopic tech is also tackling our massive global water scarcity crisis because these nanoparticles encourage much deeper root architectures, allowing plants to reach water further underground, and because they stop vital nutrients from simply washing away, we can actually see irrigation savings of 15 to 35% depending on the crop. The plants maintain their growth even under water-limited conditions, which is an absolute lifeline in drought-prone regions. And this breakdown perfectly illustrates the difference. The contrast is literally night and day. The old way, conventional urea and zinc sulfate, releases way too fast, loses a ton to leaching, and has a totally dismal nitrogen efficiency of just 30 to 50%. More than half is wasted. But with Nano-Urea zinc sulfate, you get controlled release, barely any leaching, and a staggering 80 to 90% nitrogen efficiency. The plant is actually using almost everything you give it. So, zooming back out to the macro level, the environmental wins are massive. By being this efficient, we dramatically lower the total amount of fertilizer we even need to consume. That means a direct reduction in harmful greenhouse gas emissions, way less contamination of our precious groundwater, and much better soil nutrient retention. This isn't just a win for farming, it's an absolute game changer for overall environmental sustainability and climate resilience. Let's move to our final section and see how this builds into Section 6, the future of farming. Everything we've talked about today, that's really just the foundation. Looking ahead, the innovations are thrilling. Researchers are working on wrapping these nanoparticles in biodegradable carriers made from natural sugars, or even using folic acid for hyper-targeted delivery. They're developing nano-hydrogels specifically designed for severe drought protection, and even smart moisture-responsive systems that only release nutrients when the soil moisture or pH is exactly right. You pair all of that with AI-guided precision nutrient management, and suddenly, farming becomes an exact high-tech science. Which leaves us with this pretty provocative question to ponder. Will quantum AI-assisted design and intelligent nanotech be the ultimate key to feeding our future? It is wild to think that incredibly tiny, quantum-designed particles, guided by artificial intelligence, might literally be the exact solution we need to save our biggest ecosystem and secure global food security for generations to come. Thank you so much for hanging out with me for this explainer today. Keep learning, and I'll catch you in the next one.